Here we are again talking about the Collatz conjecture, also known as the 3x plus 1 problem, and this time I'm going to definitely wrap it up on loops. I'm just going to show a brief demo and then relate it back to this property which I have been describing of inverse relationships in input-output tables of odd numbers. So let me just show you an Excel demo, small app that I wrote, and this should be, let me switch to the even odd demo, and we've got input 27, we have n equals 3, x equals 11. I've happened to have just reversed those two letters in this context. So this is 3x plus 11, and let's see what happens. We get a very nice loop. It's a very large loop because we also have the even numbers here. It actually doesn't begin with 5. 5 is actually that's the only occurrence of 5 in the sequence, I believe. It actually begins with 13. And it goes a long way down. I think that's the next one there. So that's the sequence, and doesn't look anything like the odd only sequence. So let's just switch to that one. Again, our input is 27. This is for 3x plus 11. Just remove that. Okay, 27, go away, doesn't want to. Okay, execute, and there we get the same loop, but a very different set of numbers, and the ones we've already discussed, 5 through 5. And now I want to relate back these numbers to the inverse relationship I showed before. So let's try to make sense of this. It's pretty simple actually. 5 and 13, 5 and 13. (17 and 31), 17 and 31. So these are the inverse relationships which are creating the loop. And there's some other subtleties to it. I don't claim to understand every aspect of it. There is some interesting math involved in this. I mean, there are certain other things that one notices right away, like the -8 here, which is in the calculation of the input. Also there's differences of 8 here, 5 and 13, and I believe there's another one, can't see it right now. So clearly they are very, very closely related phenomenon. This inverse symmetry you get around every input where n equals n. Every input output where n equals n, you get this inverse relationship before and after it. It's actually minus 3 and plus 3 is the difference between, so it's a -8 and 11, that's 3, and 11 and -14, that's 3. So this distribution is always the same. And the difference with 1, with 3x plus 1, is merely that there is no difference between the trivial loop and the complex loop. Or, to be a little bit clearer, input 5, output 1 is the beginning of the trivial loop. And it's the only case where there can be a complex loop in 3x plus 1.